Very good. Well, good morning, gentlemen, I guess. Based on the people in chat, where are the ladies? They need to get some work done too. Maybe they're all just watching it on replay, which is fine. Yeah, I didn't know. I felt guilty. I looked around and oh goodness, it's a little sloppy, so I had to go fix it. Okay, checking my email right now. I don't have any particular requests, so we'll just go ahead and get started. I'm gonna go ahead and stop this timer before I get that weird buzzing sound that it can make. Okay, here's a good one. All right, paper and pencils at the ready. Let's cube this thing, which means that first thing we're gonna do is we're in a circle. Bum, 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 bum. Let's circle what we think is important information. Or important numbers. When the peregrine falcon is in a dive, it can reach speeds of 242 miles per hour, making it the fastest member of the animal kingdom. Oh, very impressive. The graph below shows a proportional relationship between distance and time. How does the speed represented by this relationship compare to that of the peregrine falcon? I guess I better scroll. Okay, hang on. Let me zoom out a bit. Oh, there's a picture of the falcon. Cool. Okay. Let's go back to reading that again. The peregrine falcon is in a dive. When the peregrine falcon is in a dive, it can reach speeds of up to 242 miles per hour, making it the fastest animal in the animal kingdom. The graph below shows a proportional relationship between the distance and time, not necessarily of a falcon. How does the speed in miles per hour represented by this relationship compare to the peregrine falcon? Okay. So it's going to ask us which one's faster. Probably the speed represented by the graph is less than. The speed represented by the graph is greater than. The speed represented by the graph is equal to. Okay. So 242 miles per hour. Okay. So they show us this graph, and we're being asked to compare it to the falcon. That's not a very good falcon, but I stick by it. So the falcon, let me back that up, is 242 miles per hour, I believe is what it said. So that's miles per 1 hour. Let me scroll up and make sure that's what it said. 242. Yep. The Falcon is 242 miles per hour. And we're being asked to decide if this graph is either more greater, less than, or equal to that. So let's see. So I guess there's a number of ways to do this, but I just feel like graphing the Falcon. So are these hours in the bottom? Yep, these are hours along the x-axis. So at 1 hour, the peregrine falcon would be at 1 hour be 242. Huh. Well, check out this graph. I mean, the y-axis, if I want to graph, okay, so here's 1 hour, and 242 would be, I don't know, 200, 225. Okay, it's skipped down by 25, so that means that right here at the top would be 250. So a peregrine falcon at 1 hour would be somewhere, I don't know, right around here maybe? So this would be a peregrine falcon graph. All right, chat. So is the blue line greater than, less than, or the same as a peregrine falcon speed graph? I got one answer. Anybody else awake? Is this blue line less than, greater than, or the same as the peregrine falcon graph? It's less than because it's below it. So the correct answer for this one is that this graph is less than a peregrine falcon's speed. Yeah, because you can physically see the blue line is underneath it. That means it's less than. Yeah, I mean, if we wanted to try and take a guess, check this out. So where do we think at 1 hour, like let's say this blue line is, I don't know, a parrot or some other bird, right? At 1 hour, how far did it go? See that right there? So if we were to write the rate, the speed of this blue, it didn't give us a context. Let's just say it's a bird. If we were trying to write that out, that's going 200 miles an hour. That's the distance. That's the time. So that's if you wanted to compare it in a fraction form or a rate form or slope form, that's how you would do it. But yeah, so it's less than because it's below, and it's less than because of this fraction. At 1 hour, it has only gone 200 miles, whereas our peregrine falcon would have gone 242 miles. So the speed represented by the graph is less than. So let's try this one, then we'll move on to something different. Raquel takes her pulse in order to determine her resting heart rate, measured in beats per minute. That is probably going to be important here in a few. Beats per minute. She takes it for 3 minutes and makes the following table of the results. We'll assume that Raquel's heart is constant over the 3-minute period. Okay. So what they're saying there, when you see those words constant, Raquel's heart rate is at a constant rate, means the slope is the same. Because rates of change, speed, slope, they're all the exact same thing. The graph below shows an ideal resting heart rate of someone Raquel's height, weight, age, and general level of fitness. The x-coordinate represents minutes, and the y-coordinate represents beats. So, and then the question, never forget, we're actually looking for the actual question. Is Raquel's heart rate faster or slower than the ideal heart rate shown on the graph? So this is almost the same as our last question. So on my math practice standards, I'm going to be using my repeated reasoning skills, sort of like whatever worked on the last problem should be working for us here. Let's sort of clean up what we're doing. Okay. So so there's her information, 1 minute, 2 minute, 3 minutes. And then here is the graph. Okay, so I guess the first way we could actually do this is a physical representation. So if we were going to draw her info. At 1 minute, she had 62 beats. At 2 minutes, okay, so it's a, okay. Write that. I'm gonna write that stuff down again down here so we can all see it. So at one at 1 minute, she had 62 beats, which is really close to this blue line. But I bet it's more like in here. It's tough to say exactly. And then I believe at 2, it said 124 beats. Yeah, that's the same. That's the same ratio. So I can just multiply. So 62 times 2 would be 124. It's 124 somewhere in here. And 3 times 62 is 186. Something like that. So it's close. So there's Raquel's heartbeat status. So the question was, is her heartbeat going at a faster rate, a slower rate, or the exact same rate as this blue line? Chat, sound off. So the question is Raquel, this pink line, is her heart rate, is her heartbeat going faster than the blue line, slower than the blue line, or exactly the same as the blue line? That's the question. If we were trying to make fractions out of these intersections, at 1 minute the blue line looks to be more like 70 beats in 1 minute, and at 2 minutes, yeah, it's 140 every 2 minutes. So if you wanted to compare the fractions, you just look at the graph and do the change in y or the change in x. That's what slope is. That's what rate is. It's the y values change over the x values change. So we can compare them by just looking at the lines and agree, everyone chat, yeah, it's slower. Her heart rate is slower. Or if you wanted to compare it with the fractions, just write them out. So in this case, her heart rate is slower than the average. And for those of you guys that are interested in how health stuff works, having a slower heart rate usually means you're healthier than the person with a higher heart rate. Higher heart rate means you've got higher blood pressure, and if it's super high, it can be a sign of major health problems, hypertension, things like that. Okay. Checking email to see if anyone has sent in a request. Reading. Okay, so let's move on to something a little different. I should go ahead and answer it. It was Raquel's heart rate is slower. Okay. Okay, solutions to two variable equations. This is sort of the meat of your quiz work as well as quiz work, your assignment work as well this week. Is this zoomed in too much? I was just trying to make it bigger so everyone can see it. Go ahead, guys, on your paper pencil. Let's write this one down because we're about to do some substitution and check. Okay, step one, we got to make sense of the problem and persevere in solving it. So let's see what it says. Which ordered pair is a solution for the equation? Okay, so just so we're clear, the word solution is going to be an x value and a y value that makes this sentence true. So to make something true, they've given us these x and y values to test. Now, maybe they both work, maybe neither one of them works. So what we're going to end up doing is taking this equation, and then we're going to jam our x and y values in here and here and see what happens. So what we are looking for, text. Okay. So just to be clear, what kind of answers we're going to get. If we get something like 12 equals 12, that's going to be a true statement. It'll always work. However, if we do the math and we get something like 12 equals 9, then that means no good. So while we're crunching these numbers, let's just keep that in mind that that's what we're looking for. So now we've reasoned abstractly as to what we really want. Okay, so now the next step is to attend to precision. Let's do some very careful calculations. So here's what we do. Let me scoot math practice out of the way for a minute. Okay, so step one is I'm going to write down this equation. This guy again. This is what you should have on your own paper before we even start. Go ahead and write down 6x plus 3y equals 15. That should be on your paper. Now, we're going to rewrite that, but instead of having x and y, we're actually going to put in the x and y they gave us for coordinate A. So let's use this x and this y right now. So we'll say 6 times the x value, which is 3, plus 3 times the y value, which is negative 2, equals 15. Well, 6 times 3 is 18. 3 times the negative 2 is a negative 6. Equal to 15. So 18 plus a negative 6, using our 7th grade integer rules, that's the same as 18 minus 6. So that's going to be 12 equals 15. All right, Chad, true or false? Is 12 equal to 15? Yes, I'm glad we're all chiming in false and no. Okay, so that means that A does not work. Now, that might mean that B works or maybe neither works, but we need to test that. So let me get rid of this. And let's try this x value and this y value. So we take the same equation and we're going to write it down, but we're going to substitute. That means we're going to swap out these letters for the values. So this is going to be 6 times our x value, which is 2, plus 3 times our y value, which is also 2, and that's supposed to come out to 15. Well, 6 times 2 is 12. 3 times 2 is 6. 12 plus 6 is 18. Yo. Is 18 equal to 15? No, it is not. So I guess neither is the correct answer for this one. And that actually turned out to be the correct answer. So here's what I want you guys to do. Take this one right here. And then I want you to test out, before I get started, see if you can finish before I do. I want you to go ahead and test out this XY. And I want you to test out this XY. And remember, you are putting them in for this guy and this guy. So use the same equation twice. Let's see if either one of them makes a true statement. Hang on, someone check. Can anyone confirm or disconfirm that you can actually see this problem? I need everyone that's in chat to sound off because someone says they can't see the problem. Okay, well, if you guys can see, go ahead and start this one. Be right back. Okay, I've got some people sounding off that they've figured it out. Let's see here. Okay, step one, rewrite my equation. I can do that. Negative 7x plus 3y equals 2. Done. Step two, substitute the x and the y from part A. Okay, so that'd be negative 7 times x, which is 1, plus 3y, so that'd be 3 times the y value, which is a 3, is equal to 2. Well, negative 7 times 1 is negative 7. 3 times 3 is 9. Negative 7 plus 9 is the same as 9 minus 7. And yeah, that comes out to be true. I like a 2. I like that one. So yeah, I think that 1, 3 is a coordinate. That is a solution to this system, to this equation, to this function, this line. So those work. Okay. Well, let's test the other one. So we're going to do the same mechanics. I'm going to substitute in this negative 2 and this negative 4. So this would be negative 7 times the x value, which is negative 2, plus 3 times our y value, which is negative 4. And we've got to see if this all comes out equal to 2. Well, negative 7 times negative 2 is a positive 14. 3 times a -4 is a -12. So 14 plus a -12 is the same as 14 minus 12, which is equal to 2. So I'm pretty sure they both work. Very swish, very smart. Those the people that were chiming in that both are correct. Very nice. I'm gonna do one more of these before we move on. So this is asking you to do the same thing. So here's our equation right here. So basically at this point, after we've done 2 of them, the one math practice standard that should be kicking in is number 8. It's probably my favorite math practice standard because math is a discipline of practice. So look for and express regularity in repeated reasoning. So basically, the reasoning that we've used in the past 2 problems will work for this one as well. So I'm not even going to tell you what to do. Go ahead and launch into this one using the skills we've just used. And let's see if you can decide if A is a solution, or if B is a solution, or maybe both of them are solutions, or maybe neither of them is a solution. Go, go, go. Meanwhile, Mr. Matthews is going to be doing something on his phone, which seems really rude, but anyway. Me and the other teachers are trying to make sure we contact everyone that hasn't turned in assignments, which wouldn't be you guys. I see I'm starting to get answers coming in from chat. I better type in a few names, then I'll be able to come back and check the work. This must be super compelling on the replay. Yeah, so I watched Mr. Matthews stream, and all he did was text the other parents. Not the other parents, the other teachers. And I have to retype some of these because the phone's like, that's not a word. Okay, so let's check things same out. We're going to attend to precision, and we're going to be modeling our mathematics, basically constructing an argument proving that we are right. We've already made sense of the problems. Let's just do the perseverance part. Okay. Let me scoot my practice standards aside. So the first thing I'm going to do is rewrite my equation. So y equals 3x plus 5. Then I'm going to try this xy pair. So that'd be 11 equals 3 times x, which is 2 in this case, plus 5. So 11 would equal 3 times 2 is 6 plus 5. Well, that seems promising. 6 plus 5 is 11. So yeah, I like A. I can switch up my colors and let's try this x and this y value. So y sub 13 equals 3 times x, which is 3, plus 5. Okay. So 13 equals 3 times 3 is 9, plus 5. Uh-oh. I don't think so, because this one's trying to tell us that 13 equals 14, which is no bueno. So I don't think we can pick B as a solution to this system. So what we would only pick is A. Yep. Yeah, double check that, chat. If you message me saying that both are true, be wary. 3 times 3 is 9, and 9 plus 5 is 14, which is definitely not 13. Let's try a different type. We'll come back to that one if you guys really want to. Let's try something a little different. Okay, this is going to be very similar to what we just did, but they're phrasing it and showing it to you in a slightly different way. So what they've done here is they represented the information they just gave you slightly differently. They're giving you one of the two variables, but your brain should be saying, hey, this sounds really familiar. So we got this equation, and then they give us some information right here. So they're giving us an x value, and they are asking us to solve for the missing value. In this case, it's the y. We just don't know what y is. Okay, not a big deal. So here's how this is going to work. Where'd my math practice standards go? Get those in here. Okay. So complete the missing value in the solution. Okay, again, the solution is getting the coordinate pair that fits this equation. So so we've made sense of what it's asking us to do. I understand what the x and y values are, so I guess I'm sort of reasoning abstractly. By the end of this, I will have constructed an argument to prove to you and myself that we have the right answer. We're going to have to model with our mathematics. We haven't gotten there yet, but we will. We're going to attend to precision, be very careful with our numbers. And yeah, I think we're going to be using a lot of repeated reasoning. The stuff we just did is really going to help us out here. So let's see. If I were to rewrite this equation with this x and this y value, that would be y equals, because we don't know what y is, but we do know what x is. So I can say 4 times 3, which is our x value, minus 9. So all I did was rewrite the equation, but instead of using x, I used the actual value that they gave us, which is 3. So y equals 4 times 3 is 12, and 12 minus 9 is 3. So what did we just decide on? Well, what we're saying is that when in this system, in this equation, in this function, on this line, when x is equal to 3, y must be equal to 3 because of all this arithmetic we just did. Cool. I'm going to get another one of those. Here we go. So here's our equation. Right here. And they gave us, hang on. Back of it. So there's the equation. The x value is missing, but they did give us the y value. So what we want to do is take that y value and jam it in right there and then do some arithmetic. So everybody on your papers, here we go. This is what you should be writing down, and we'll see what you get. So 4x, we still don't know what x is, so we can't do anything with that. 4x plus, and this is where we can put in our y value. We'll do it and we'll nest it in parentheses at first. Okay, let's see, chat. Let's see what you guys can make of that. So we've got 4x plus negative 6 equals 10. That's going to involve some inverse operations. Let's just see what you can do before I actually tell you how to do it. So I'll give you a minute just to kind of tackle this and see what you get. While I discuss with the other teachers, all these students, we got about, I don't know, about 10 eighth graders that we're worried are just going to call our bluff on whether or not they actually have to turn in work. We'll see. Now I'm looking for the perfect emoji that just says, Okay. You've had your minute. Here we go. So if I want to get x by itself, so we end up with x equals stuff, I'm going to have to start shedding some of this stuff. What's the opposite of adding a -6? Adding a +6. So no one's going to tell you that you had to do that. That is part of your intuition. You have to just sort of, because you've done enough practice, understand how this works. Now, if I add 6 on this side, I have to add 6 on this side because equations are balanced. So the abstract rule that we are abusing here is that anything combined with its opposite is equal to 0. So that's our little abstract rule we're going to be using. So -6 plus 6 makes 0, and that's what we wanted to have happen. So we still have 4x. -6 plus +6 is 0. 10 plus 6 is 16. Now, the other abstract rule we're going to be abusing is that anything divided by itself is equal to 1. So if we were to divide this term by 4, 4 divided by 4 is 1. So you just end up with 1x. But to make sure everything stays balanced, we've got to divide this side by 4 as well. So what you end up with is 1x is equal 16 divided by 4 is 4. So apparently, when in this system, in this equation, on this line, when y is equal to -6, x has to be equal to +4. There it is. Sometimes it's hard to check, and like sometimes I make little notes about who attends my sessions, and sometimes you guys make it hard on me when you give your name something like legendary X Ken something. All right, try the next one, guys. Here we go. I want everyone that's in chat to sound off before I actually work it out, but I'm not going to give you that big of a head start. Here's the equation: y equals 3x minus 7. They're just giving you the x value, but the missing value is the y. So see if you can figure it out. Ooh, we got some quick responses this time. Wait on a few other people to give it a try before I just flat out tell you. In case you didn't know how to get started, since they give us the x value and the x is right there, I'm going to rewrite the equation as y equals 3, but instead of an x, because they gave that to us, I can just plug that in as 1 minus 7. So now we're just trying to figure out what would the y be in this system when x is equal to 1. So y equals 3 times 1 is 3 minus 7. So if x is equal to 1, y would be equal to, drum roll, how many people got it right? Wish I could just give people gold stars in chat. Is it possible? There's got to be. I wonder if this has some sort of a tool. Nope. Anyway, So 3 minus 7 is correct. Several of you got it. -4. So in this system, on this line, in this function, whenever x is equal to 1, y has to be equal to -4. Okay, we got a few more minutes here. I haven't received any specific requests, but guys, why don't we just take a look at our class assignments, because today is the day that I'm going to start looking at people's turn in work so that if they want to try and correct it before Friday, today is sort of the day I want them to turn it in. Let me pull up you guys' assignments. Okay, so if I'm looking at, here we go. So this is assignment number 3. Like problem 2 looks like something we were just doing a little while ago. So here's what we'll spend our last 7 minutes talking about: is which of these problems, which ones is sort of like, oh no, how do we do that one? So problem 1, you're driving cross country road trip. You're driving at 60 miles an hour. What is the slope of the line? Oh goodness, I think someone asked me that question on stream, and I just flat out answered it for them. Okay, we might come back to one just like that. Problem 2, which ordered pair is the solution to this one? Now, we just did several of those here today, so anyone watching should be able to figure this one out. You plug in this x and y value here and see if they come out to be true or false. Maybe it's one, maybe it's the other, maybe it's both, maybe it's neither. Problem 3, complete the missing value. Okay, that's what we just did. So they gave us the x value, so you jam that in here. You'd substitute that in and solve for what y is with some inverse operation work. Problem 4 is another ordered pair solution where you check both the x and y and see if it comes out to be true or false. Again, problem 5 is where you jam in the y value and see if the x value what the x value comes out to be. And that's it. So I guess the only one we really haven't touched on, I guess, explicitly would be this first problem. You're driving on a road trip. Okay, so I'm just gonna give you guys some hints on this. So when it says a speed of 60 miles an hour, they are wondering, when I say they, I mean the people that wrote this question, they're wondering if you understand that these things mean the same thing. So rate of change, slope, speed, these all mean the exact same thing. They're just different contexts. So, hintity hint hint, when they tell you the speed is 60 miles an hour and they're asking you for the slope, if you understand that rate of change and slope and speed are all the same thing, I'm winking, there's not a whole lot of actual calculations you have to do to get this one right. And I think that'll be my signing off hint of the day for your classwork. So, if you want correction notes on your work, turn it in by 3 p.m. today, and then you can unsubmit and resubmit change answers by Friday, because they are due by 3 p.m. on Friday for a grade. Please get a hold of your friends and look in on them and check sure they are okay, and make sure everyone's turning in their work, because we got about 10 eighth graders that didn't turn in anything last week, and those include eighth graders whose parents I spoke to. So, I hope they're doing all right. I hope they're not suffering from some technical difficulty, what makes it difficult to get their work turned in. But be that as it may, if you are going to want to try and correct your answers, turn in your work by 3 p.m. today, and then you can take a look and fix things before Friday. So I guess until next time, which should be tomorrow, same place, same channel, I'll see you guys next time.